All right, welcome back to the deep dive. Today we're going to be taking a look at AI video generation. We've all seen those incredible short video clips created from text prompts.
Yeah, it's pretty amazing stuff.
Right. But what if you want to generate something a bit longer? Something with multiple evolving scenes.
Yeah, that's where things get a little tricky, definitely.
Yeah, and that's exactly what this paper tackles.
I think it's really cool how this research actually offers a solution, a clever one. It's like, how do we make these longer videos from a series of prompts and keep the quality up, and not have to retrain the entire AI model every time?
Totally. That retraining is a huge resource drain. So the paper we're looking at is titled Tuning-Free Multi-Event Long Video Generation via Synchronized Coupled Sampling. And it's a collaboration between Caste and Adobe Research.
The tuning-free part is super important. Like you were saying, retraining these big AI models, it takes forever, costs a ton.
Exactly. So finding ways to extend what they can do without retraining is a big win.
Absolutely. So the core idea, right, is to figure out how to generate these longer videos. You give it a bunch of text prompts, each describing different events, but you don't want to have to retrain the whole underlying model. Use what we have, but make it even better.
Right. Build on that foundation. So let's dive into this tuning-free approach.
Okay, so right off the bat, the abstract highlights SYNCO AS. It stands for Synchronized Coupled Sampling. It's an inference framework. What that means is it works with pre-trained text-to-video models. So we're not talking about training a new model. We're talking about using what already exists to generate these longer multi-event videos, which is pretty impressive.
That's really efficient. It leverages the power of those existing models.
Yeah, exactly. And they specifically call out a problem with a lot of current methods. Like some methods, they do a pretty good job of making smooth transitions from frame to frame.
So it doesn't look all choppy and weird.
Right, exactly. But the problem is, over a long video, the content can drift. Like things might change in ways that weren't intended, or the style might shift.
And it just doesn't feel cohesive, yeah.
Right. And the original instructions, like the prompts, they kind of get lost along the way. So SYNCO AS comes in, and its goal is to tackle this long-range consistency problem. How do we keep everything on track throughout the entire video?
So how does it do that?
So their big innovation is synchronizing what they call denoising paths. If you're familiar with diffusion models, they start with random noise and then gradually remove that noise to create something structured. In this case, a video. So SYNCO AS makes sure that this noise removal process happens in a coordinated way across the entire video, not just between frames that are right next to each other.
So it's looking at both the small details and the big picture.
Yeah, exactly. It's thinking about how the video evolves from start to finish and making sure things stay consistent.
That makes sense. So they're not just using one technique to achieve this.
Right. They actually combine two different sampling strategies. To get that smooth flow between moments in the video, they use something called reverse sampling, specifically D-DEM, which stands for denoising, diffusion, implicit models. D-DEM is known for being efficient and producing high-quality results.
Got it. So D-DEM handles the moment-to-moment flow, but what about the overall coherence, making sure everything hangs together?
Yeah, that's where the second strategy comes in. An optimization-based sampling method called collaborative score distillation, or CSD. CSD is really cool because it lets different parts of the video, what they call samples, influence each other during the generation process. They're not just generated in isolation.
Interesting. So it's like they're working together to achieve a unified result.
Exactly. But it's not as simple as just throwing these two techniques together. The researchers found that simply alternating between D-DEM and CSD can actually cause problems. They called it misalignment in the denoising trajectories.
So they need a way to make these two methods work together seamlessly.
Right. Because otherwise you might get weird jumps or inconsistencies.
So what did they do? How did they synchronize them?
They introduced two mechanisms. First is what they call a grounded time step. It's basically like a common timeline for the noise removal process. It makes sure that D-DEM and CSD are working at comparable stages of noise removal so they don't clash.
So everything stays in sync.
Precisely. And the second mechanism is a fixed baseline noise. During the CSD part, they use a consistent noise pattern. This helps to prevent the different parts of the video from becoming too similar, losing their unique qualities.
I see. So it maintains the individuality of each segment while ensuring overall coherence.
Exactly. The paper also highlights the use of a structured prompt.
Right. I was curious about that. How does the prompt structure play into this whole process?
Well, instead of just giving the model one long prompt, they use a structured approach. They have a global prompt that describes the overall scene. And then they have local prompts for specific segments of the video to guide the action and dynamics in those parts.
So it's a way to provide more specific and organized instructions.
Yeah, exactly. And to make things even more interesting, they actually used a large language model, GPT-4o, to help generate these structured prompts.
Wow, so it's like AI helping AI.
Right. It's pretty cool.
So with all these mechanisms in place, did SYNCO AS actually work? Were they able to generate those long, coherent videos they were aiming for?
The results were really impressive. They did a bunch of experiments, both visual comparisons and quantitative measurements, and across the board, SYNCO has outperformed previous methods. The videos were smoother, more consistent, and better aligned with the prompts.
That's great. So their approach was validated in their testing.
Yeah, definitely. And in their introduction, they actually lay out their key contributions. They see the SYNCO AS framework itself as a major innovation. Then, of course, the synchronization mechanisms, the grounded time step and fixed baseline noise, those are critical. The structured prompt idea is also important. And finally, they did a ton of testing across different text-to-video models, which shows that this approach is flexible and broadly applicable.
That's really valuable. It means it has potential beyond just one specific model.
Exactly.
So to understand this work in context, let's go back to the background section of the paper. They provide some context about existing research.
Right, so they start with a quick overview of diffusion models, which are the basis for a lot of this AI image and video generation. They explain how diffusion models learn to denoise data, going from random noise to a structured output.
And they revisit D-DEM, which you explained earlier, as a specific way to sample from those diffusion models.
Exactly. They also explain classifier-free guidance, which is a commonly used technique to guide diffusion models with text prompts.
Okay. And then they delve into two other important techniques, scored distillation sampling, or SDS, and its collaborative version, CSD.
Yeah, so SDS is a way to use diffusion models for more than just generating images or videos. You can actually use them to optimize other things. It's kind of like using a master painter to not just paint, but also to critique and refine the work of other artists.
Interesting analogy.
And then CSD takes this idea a step further and applies it to multiple samples so they can learn from each other and become more consistent.
I see. So how does this relate to long video generation?
Well, they explained them before SYNCOs. A common approach for generating longer videos without retraining was fusion-based methods. Basically, you break the long video into shorter segments, generate each segment with maybe different prompts, and then blend those segments together.
That seems like a logical approach, but it sounds like there are some limitations.
Yeah, the main issue is that while you might get smooth transitions where the segments meet, the overall video can still lack consistency. The different segments, even though they're blended, can kind of drift apart in terms of style and content.
So the longer the video, the more noticeable these inconsistencies become.
Right, exactly. And that brings us to the key observation section of the paper, where they really dig into why these previous methods haven't completely solved the problem.
What were some of their key insights?
They first looked at a specific fusion-based method called Gen-L video, which focuses on blending the probabilities of the generated frames. And they found that this blending process actually causes the generative processes for different parts of the video to diverge, like they start going in different directions.
So instead of unifying them, the blending is actually pulling them apart.
Yeah, that's what their analysis showed. And this divergence leads to those unnatural transitions, like an object suddenly changing appearance.
I see. So blending alone isn't enough. What about their experiments with CSD? Directly applying that to long video generation work?
Interestingly, while using CSD did help to keep the generative processes more aligned, the resulting videos were actually low quality. They had a lot of noise and artifacts.
That's surprising. Why do you think that happened?
They think it's because in typical CSD applications, like image editing, you have a starting image, something structured to work with. But with video generation, you're starting from pure noise. So even though the generative paths are aligned, there's no clear guidance, no initial structure to build upon.
Okay, so that's a key difference. So that brings us to the method section of the paper, where they finally unveil SYNCO AS in detail.
Right, so the goal of SYNCO, as they emphasize, is to combine the best of both worlds, smooth transitions and long-term consistency.
And they do this by combining those two sampling strategies we talked about, D-DEM and CSD.
Exactly. And they use a three-stage process that gets repeated at each step of the denoising process. First, they do temporal co-denoising using D-DEM, focusing on those overlapping segments to make sure the transitions are smooth. Then they use CSD to refine the output, taking into account the global context and making sure everything stays consistent. And finally, they revert back to a slightly noisier state to prepare for the next iteration of the cycle.
Okay, so it's like a back and forth, constantly refining both the local details and the overall coherence.
Yeah, exactly. And remember those mechanisms for aligning the denoising paths, the grounded time step and fixed baseline noise. They play a crucial role here.
Right, let's revisit those.
Okay, so the grounded time step ensures that the D-DEM and CSD processes are working at the same stage of denoising. It's like making sure everyone is looking at the same blueprint at the same time. And then the fixed baseline noise during the CSD stage ensures that each segment maintains its unique characteristics. It prevents them from all becoming too similar.
I see. So these mechanisms are really what makes the synchronized coupled sampling work.
Exactly. They also found that applying the full SYNCO AS process is most important during the early stages of denoising. Once the basic structure of the video is established, they can rely more on D-DEM for local smoothing.
That makes sense. And what about the structured prompt? How does that fit into all of this?
The structured prompt provides more targeted guidance throughout the generation. The global prompt sets the overall scene, while the local prompts control specific events. And remember, they actually used a large language model to help create these prompts.
That's a really interesting detail. It shows how these different AI techniques can work together. So the experiment section is where they really put SYNCO AS to the test.
Right, and they didn't hold back. They tested it on 48 different long video scenarios, which is really comprehensive. These scenarios included things like moving objects, camera movements, changes in background, and complex compositions. And they implemented SYNCO AS across 4 different text-to-video models.
Wow, so they really wanted to make sure it was robust. What were their main comparisons? Who were they competing against?
Their main comparisons were against other tuning-free methods, specifically GenL video and FIFO diffusion. These represent the state-of-the-art in extending existing models without retraining.
And how did they measure the quality of the generated videos?
They used a combination of metrics. They used vBench, which is a standard benchmark for evaluating video generation models. It looks at things like temporal consistency and per-frame quality. They also measure the number of scene changes and use CLIP scores to quantify how well the videos aligned with the prompts.
Okay, so a pretty thorough evaluation.
Yeah.
And what did the results show?
The results were really positive. SYNCO AS consistently outperformed the other methods.
Yeah.
It produced videos that were smoother, more consistent, and better aligned with the prompts.
That's great to hear. It sounds like SYNCO AS really delivered on its promise.
Yeah, it did. And they also did an ablation study.
Which is essentially a way to figure out which parts of the method are actually contributing to its success, right?
Exactly. By removing or altering different parts of syncos, they were able to show that the grounded time step, the fixed baseline noise, and the structured prompt were all essential. Without those things, the performance dropped significantly.
So each piece of the puzzle is important.
Right. And finally, in the related work section, they discuss how SYNCO AS fits into the broader research landscape. They emphasize that while other methods exist for long video generation, they either require retraining or they struggle with long-range consistency. SYNCO, they argue, offers a solution to this problem by synchronizing the generation process at multiple levels.
So it's a significant advancement in tuning-free long video generation. Okay, so that's a really great overview of the research. Now let's move on to our novel notions segment, where we like to explore potential future directions inspired by this work. What ideas has this paper sparked for you?
You know, the paper's focus on synchronizing different parts of the generation process got me thinking about other applications beyond just video. They were able to coordinate local frame generation with global narrative consistency. What if we applied similar ideas to generating long, coherent audio narratives from text?
That's a fascinating idea. How would that translate to the audio domain?
Well, imagine breaking down a long piece of text like a story or a script into segments.
Okay, like the frames in a video.
Exactly. For local smoothness in audio, maybe a D-DEM-like approach could handle the transitions between those segments, making sure things like tone, pace, and background sounds flow naturally. And then for global coherence, making sure voices stay consistent or the emotional tone of the story stays consistent or musical themes recur, maybe we could adapt a CSD-like method.
So it would be working on audio features instead of visual features.
Right. Instead of visual characteristics, it would operate on those higher level semantic embeddings of the audio.
I see. So it could ensure that a character's voice remains the same throughout a story, or that a musical composition retains its overall structure even as it evolves.
Exactly. It's a really interesting thought.
What kind of new challenges might arise in applying this to audio?
Oh, tons. I mean, first we'd need to define what smoothness and coherence even mean in the context of audio. What makes an audio transition jarring? How do we measure consistency in things like tone or theme? We might have to look at existing audio generation techniques and see if we can adapt them to incorporate these ideas of synchronization and multi-scale generation.
Right, it would require a whole new set of tools and metrics.
Definitely. But the core principles from this paper, this idea of balancing local quality with global structure, it feels like it could have really broad applications.
Absolutely. Well, unfortunately, that's all the time we have for this deep dive. Be sure to check the link below if you want to explore the paper in more detail. And as always, we leave you with a question to ponder. What other creative domains could benefit from this idea of synchronizing different levels of the generative process to achieve both local quality and global coherence?
Until next time.
Thanks for joining us.